students, welcome to my new classroom, and today I am going to deliver my speech on a new chapter, on a new topic for the students of class 10, and today I am going to discuss about the chapter matrices. Okay, so first question can arise in your mind that what is matrices and why the chapter name is matrices. Actually, we have to learn about the chapter matrix. Okay, but chapter name is matrices here because of matrices is the plural form of matrix. Okay, matrix is singular form. So first you have to know what is matrix. Okay, so in simple word, matrix means a rectangular array of some numbers. Okay, so again you have to know about what is array, is it? So array means, simply in simple word, array means arrangement of data. Okay, so we can arrange the data into different way, like linear way also we can arrange. Suppose I am rectangular array or square, it can be square array also. Okay, so who have the computer, they know about the array. Okay, so for your better understanding, I am considering an example so that you can understand much better what is matrix. Okay, I am considering the example, considered here an example so that you can understand much better what is matrices or what is matrix. Okay, so read the example. Suppose 4 types of food A, B, C and D produced by 3 different companies X, Y and Z. Okay, there are 3 different companies. One name of the companies are X, Y and Z, and they are each of the company produced 4 different type of foods. Okay, next time the amount of food produced by the company X are 10, 8, 3 and 5. That means the company X produced the food of type A 10 amount is 10, B type foods amount is 8, for C type foods amount is 3 and for D type foods amount is 5. Similarly, the company Y produced this 4 type of foods, this amount 4, 0, 7 and 6, and hence Z are 6, 9, 2, 3 respectively. So this is an information. Okay, so easily we can arrange this concept orderly, okay, into a rectangular form. Okay, see, I am arranging it. Basically this is the data, this is the information, means this is data. We can arrange it so that easily we can understand all the information from the table. Okay, so we can arrange all this information in a table, in a rectangular table. Okay, so look at the board, you will understand. Not exactly solution, this is actually arrangement. Okay, how many types of foods are there? Here ABCD foods are there at 3 different companies. Okay, I am writing here company and suppose this is for foods. So how many companies are there? There are 3 different companies are there, X, Y and Z. So this is X, this is X, Y, Z, this 3 companies. Okay, and food types are A, B, C and D. So if we write the amount of food produced by company X, then X produced 10, 8, 3 and 5 respectively. So 10 amount of food A, 8 amount of food B, 3 amount of food C and 5 amount of food D. Similarly for Y, 4076, 4076, and for Z, 6923, 6923. So from this table easily we can identify that which company, which food produced maximum. As for example, let's see food type A. Food type A maximum produced by company X. Understood? So from this table we will get all the information. Okay, so we will get the advantage if we arrange this data into this form. So this is called a rectangular arrangement. See, this is the shape of rectangle. So this is called rectangular arrangement. So if we arrange all these data into a rectangular form, then this is called matrix. Okay, generally we will avoid this part, company name, food, all these things, and in your exercise this type of story will not be there. Okay, direct matrix will be there. Suppose we can generate a matrix from this part. So since these are the collection of data, and if we write this collection of data into first bracket, we can use the first bracket to we can write it into the first bracket. Then this is the matrix. Okay. Sometimes we can use the third bracket also. Okay. This also we can use that third bracket. 10, 8, 3, 5, 4, 0, 7, 6, 6, 9, 2, 3. We can use the third bracket also. And this is also matrix. Okay. In your book, that means in the book of class 10, they have used third bracket to represent a matrix. So hope you get the idea that what is matrix. In simple word, matrix means arrangement of data into rectangular or square ways. A simple array. Okay. So actually this is the new concept for all the students. This is the new concept, matrix. So since here matrix is the new concept to all of you, so we will try. Is it possible to apply all fundamental operations on the matrices? Okay. So before that discussion, that fundamental operations, that is addition, subtraction, multiplication, division, applicable on matrices or not, I would like to discuss some different type of matrices on the basis of order. Okay. So first you have to know about order. What is order? So look at the whole. If you consider this matrix, then these are called row. Okay. In this matrix, these are called row. These are called row. Okay. So how many rows are there in this matrix? First, second, third. 3 rows are there, and these are called column. If you consider, then these are called column. So in vertical way, we have to count the column, and in horizontal way, we can count the rows. So how many rows are there? 1, 2, 3. Total 3 rows are there. So number of row is 3, and number of column, we have to count in vertical way. First, second, third, fourth. So number of column is 4. 1, 2, 3, 4. Okay. So from the matrix easily we can count the number of row and number of column. Clear? So next definition, order of a matrix, order or dimension of a matrix. Okay. Next definition, order or dimension of a matrix. What is order and what is dimension of a matrix? Okay. Suppose I am considering an example. Let capital A equals to, I am using first bracket, okay, 2 5 3 9 1 0 minus 2 3 5 7 2 1. Then clearly this is a matrix. Okay. So first count the number of rows. Here number of row what? Number of row. So number of row we can count along horizontal. So 1. This is one row. Second, third. So 3 rows are there. And number of column. 1 2 3 4. So number of column is 4. Okay. So dimension means actually number of row cross number of column. Okay. Dimension of matrix or order of matrix equals to order of a matrix is number of row cross number of column. So what is the order of this matrix? Number of row is 3 and this is 4. So order of this matrix or dimension of this matrix is 3 cross 4. Okay, we will not multiply here. Don't write 3 into 4 equals to 12. Okay, we will keep into this form only. That order of this matrix is 3 cross 4. And generally we will write here into this position in short, that 3 cross 4. So order always represents that number of row cross number of column. Okay, suppose I am giving you only that suppose B is a matrix of order 2 cross 3. So easily you can identify about the number of row and number of column. How many rows are there? 2 rows are there and 3 columns. So this matrix will be from 2 rows. That means some entry will be there. 3 column. So the matrix will be into the from this. Okay. In the place of star there will be some entries, some data. Clear? So this is the order of matrix. Next, on the basis of order of matrix, we can classify the matrices. Okay. Next, different type of matrices. Types of matrices. On the basis of order of the matrix, we can classify the matrices. The first one is rectangular matrix, second one is square matrix, row matrix, column matrix, zero matrix or null matrix, and identity matrix. Okay, so I will discuss one by one. First, rectangular matrix. In rough word, rectangular matrix means a matrix is said to be a rectangular matrix if the shape of the matrix is like rectangle. Okay, what is the shape of rectangle? Rectangle means one side will be greater and the side will be less. Okay, so rectangular matrix means if you consider here an example, suppose A equals to 2 3 1 0 5 1 2 3 7 minus 1 2 minus 2. Then see, this matrix is of shape of rectangle. Why? There are 3 elements along this and along this there are 4. So one side is less and the side is greater. So this is the rectangular matrix. This is the example of rectangular matrix. This is the example of rectangular matrix. Okay. So if we consider one more example, then 2 3 5 1 7 9. This is also a rectangular matrix. So this can't be a definition that if the shape of the rectangle, shape of the matrix is like rectangle. So you have to give the definition by using the concept of order. Okay, I have considered here 3 matrices. First one is like the shape of rectangle. So this is rectangular matrix. For the second one, this is also shape of rectangle, so this is again rectangular matrix. And for the third one, C equals to this. This is the shape of square. See, there is 3 elements, and along this there is also 3 elements. So this is the shape of a square, so this is square matrix. Okay, so this can be a definition that since the matrix looks like rectangle, so it is rectangular matrix. It's like square, so it is square matrix. So we have to give the definition in terms of order. Okay, so in terms of order means here the shape is like rectangle since the number of row and number of column, okay, number of column is distinct here. See, here number of row what? If we write the order of matrix here, in order of first matrix is number of row 1, 2, 3. So 3 rows are there, and column 1, 2, 3, 4. So order of this matrix is 3 cross 4. Okay, so here number of row and number of column are distinct. Okay, so we can give the definition of rectangular matrix. A matrix is said to be rectangular if number of row not equals to number of column. Is it clear? Number of row is not equals to number of column. So identify a number of row and number of column distinct. So this is rectangular matrix. If we check here, the number of row will be 1, 2, 3. So 3 rows are there, and column 1, 2. So 3 cross 2. So this is also rectangular matrix. And for this, the shape is like square. So this is square matrix. Why? So we can give the definition in terms of order that a matrix is said to be square matrix if number of row equals to number of column. In the case of rectangular matrix, number of row not equals to number of column, and in the case of square matrix, number of row equals to number of column. So you will get the idea from the name only. Okay, you will get the idea from the name. Okay, name carries all the characteristics of this type of matrix. So order of matrix is here, number of row 1, 2, 3. Number of column 1, 2, 3. So this is the square matrix. So if you hope you got the idea what is rectangular matrix, what is square matrix, and on the basis of order, how can we give the definition of rectangular matrix and square matrix? In simple word, I am telling again, rectangular matrix means number of row not equals to number of column. In the case of square matrix, number of row equals to number of column. Okay. Next definition, row matrix. Very easy. You will get the idea from the name only. Why? Row matrix means the matrix which has only one row. Okay, the matrix which has only one row. And column matrix, the matrix which has only one column. Let me consider an example, then it will be clear to you. Suppose A equals to 2, 3, 5. B equals to 5, 7, 9. C is another matrix 1, 0, 2, 5, 7. D equals to 2, 3, minus 1, 7. Okay, I have considered here 4 matrices. Here this is a collection of data. Okay, see the first example, the matrix A. This matrix has only one column. See, only one column is there. And for the matrix B, only one row is there. How many rows are there? Only one row. For matrix C, only one row. For matrix D, only one column. So here A and B are column matrix, since only one column is there, and B and C are row matrix. Okay, so let's go to find the order or dimension. So to write the order or dimension, order means number of row into number of column. So here it is clear that number of column is 1. Okay, so I have written here number of column, but we have to write first number of row. Okay, so we have to count the number of rows along horizontal line. So how many rows are there? 1, 2, 3. Okay, and column along this direction only 1. So number of row is 3 and number of column is 1. What is the order of this matrix? Number of row is 1 since only 1 row, and number of column 1, 2, 3, 1 cross 3. Okay, always we have to count the row into this horizontal form, and we have to count the column into vertical form 1, 2, 3 into this way. Okay, for this number of row is 1 and number of column 1, 2, 3, 4, 5. So 1 cross 5. For this number of row 1, 2, 3, 4 and number of column only 1. Okay, so we can say that row matrix means the matrix has only one row, and column matrix means the matrix has only one column. So this completes the definition of row matrix and column matrix. Hope you get the idea. Actually, all the characteristic carries by the name only. Next, zero matrix or null matrix. Okay, this is a very important part. If all the entries of a matrix is zero, all the entries means all the data. If in a matrix all the entries are zero, then that matrix is called null matrix or zero matrix. Okay, actually null matrix or zero matrix is denoted by O, not zero. Okay, this is O. Okay, O equals to 0, 0, 0, 0, 0, 0, 0. See, all the entries are 0 here. So what is the order of this matrix? 3 rows and number of column is 4. So this is null matrix of order 3 cross 4. Okay, if all the entries 0, then this is zero matrix simply. So zero matrix of order 2 cross 2, 0, 0, 0, 0. This is the zero matrix of order 2 cross 2. Is it clear? Next, identity matrix. Identity matrix generally denoted by capital I. Capital I stands for identity. Okay, capital I. This is very important. That's why I am writing into this way. Capital I. I equals to most important part, that identity matrix is always a square matrix. Okay, always a square matrix. It must be a square matrix. So if we try to write the square matrices of order 2 cross 2, then 1, 0, 0, 1. This is order 2 cross 2. Of order 3 cross 3, I equals to 1, 0, 0, 0, 1, 0 and 0, 0, 1. This is identity matrix. For this is 3 cross 3. Okay. For 4 cross 4, identity matrix will be into this form 1, 0, 0, 0. Actually, first we have considered here 1, rest all the elements 0. Next we will consider second element 1 and rest all the elements 0. Next 0, 0, 1, 0. 0, 0, 0, 1. This is the identity matrix of order 4 cross 4. And I will discuss in my another video that why this matrix is called identity matrix and what is the characteristic of identity matrix. Okay, actually we need a complete class to discuss all these things. Okay, next I will discuss about operations on matrices. Okay, in mathematics there are 4 types of operations: 1 addition, subtraction, multiplication and division. Okay, so addition, subtraction, multiplication and division. Okay, in the case of matrix addition, matrix subtraction, matrix multiplication and matrix division, I will discuss later about matrix division, whether it is exist or not. But in your syllabus there is matrix addition, matrix subtraction and matrix multiplication. Okay, one important thing is all these 3 operations you can do in the case of matrices, in general you can't add two matrices, you can't subtract two matrices, and you can't multiply two matrices. You can do these three operations with some restriction. Okay, so let me consider I am discussing about matrix addition. Okay, let A equals to 2, 5, 7, 3, 1, 2. Suppose this is one matrix and another matrix B equals to 1, 0, 2, 3, minus 1, okay, 3, 1, 5. Suppose I have considered two matrices. One is A, another one is B. Okay, so what will be A plus B? If you think about A plus B, then you can able to add these two matrices. Why? We are having only one way to add to these two matrices. How? We have to add the corresponding entries. That means first element with first element, second with second. We don't have any other options except this. Okay, so this is matrix addition, simple. Okay, so A plus B will be 2 plus 1, that means 3, 5 plus 0, that means 5 itself, 7 plus 2, 9, 3 plus 3, that means 6, 1 plus 1, 2, and 2 plus 5, 7. So this is the addition of two matrices A and B. Clear? So hope you get the idea that how to add two matrices. Okay, so in simple, matrix addition means we have to add the corresponding entries of two matrices. Corresponding entries means, say I have considered here the first element, that means I have considered here also first element. This is called corresponding entries. Okay, so you can ask me now that sir, where is the restriction? No restriction is there. In general, we can add any two type of matrices. So is it true that any two type matrices you can add? No. As for example, I am considering an example, then it will be clear to you. Suppose I am considering A equals to 2, 3, 5, 1. And another matrix B equals to 5, 3, 1, 2, 7, 9. Okay. Now if we try to add these two matrices, then A plus B, we are trying, okay. We don't know whether it is possible or not, but we are trying. 5, 3, 1, 2, 7, 9. Now is it possible to add these two matrices? Suppose you have add 2 and 2, very good. 2 and 5. Here 3 with this 3, this 5 with this 1, this 1 with this 2, but there is no element or no row, so that you can add these two with this part. So is it complete the process? No. So in this case, we can't do the addition between these two matrices. Why? So since matrix addition says that we have to add the corresponding entries, so two matrices, yes, addition is possible if two matrices are of same order. So this is the restriction, that matrix addition is possible only when the matrices are of same order. Is it clear to you? Now, hope you get the idea about matrix addition. Next, some properties, some important properties of matrix addition. Properties of matrix addition. Suppose you consider two matrices A and B, then A plus B and B plus A. These both will give us the same result. So A plus B and B plus A same. So this rule known as commutative property. Commutative property on addition. Okay. And A plus B plus C, where A, B, C are matrices, okay, equals to, if we add the first two matrices A plus B, after that C, then this is also true. This property holds. This is called associative property. Associative property. Okay, so these two properties hold for matrix addition. Commutative property and associative property. They can commute with each other and they can associate. Clear? Okay, next, matrix and subtraction means same concept. You have to just subtract the corresponding entries, okay, or corresponding elements. Clear? So I am considering an example, then it will be clear to you. Matrix subtraction. Next heading, matrix subtraction. By an example you can understand. Suppose matrix subtraction. Suppose I am considering an example. A is a matrix 2, 3, 5, 1. Okay, and B is another matrix. Suppose 5, 7, 2, 3. Then A minus B will be subtraction of corresponding entries. You can write subtraction of corresponding entries. You can write it once for your advantage. Minus 5, 7, 2, 3. So if you subtract the corresponding entries, we will get 2 minus 5 means minus 3. 3 minus 7 means minus 4. 5 minus 2, that means 3 only. 1 minus 3 means minus 2. So this is our A minus B. Also, matrix subtraction possible if two matrices are of same order. Okay. Otherwise, you will not get the corresponding entries. Okay. If you will not get the corresponding entries, then how could you apply? Understood? So this is the concept of matrix subtraction, and the properties is very important that matrix subtraction is not commutative. Okay, like the number system. Actually, matrix addition is commutative, since we know that in the case of addition, 2 plus 3 and 3 plus 2 give us the same result. And this is a number system. The concept is same, that 2 plus 3 and 3 plus 2 will give us the same result. So in this case, matrix addition, numbers, in real numbers, addition was commutative, but in the case of subtraction, 2 minus 3 and 3 minus 2, these two are not same thing. These two are not equal. So we can conclude that since we have to subtract the corresponding entries, so we will not get the same values. So we conclude that A minus B and B minus C, these two are not equal. Understood? This will not give us the same result. Clear? Scalar multiplication with a matrix. Scalar multiplication. So scalar multiplication means suppose A is a matrix 2, 3, 5, 1, 7, 9. Suppose we are going to multiply 2 with the matrix A, then 2A equals to what? What will be 2A? 2A will be, obviously we have to multiply these two with each and every entries of this matrix. 2 into A, that means we have to multiply 2 both sides. So 2, if we multiply, then we have to multiply with each of the entries. So 2A will be 4, 6, 14, 10 to 18. So this is 2A. So this is the concept of scalar multiplication. Since A was a matrix and 2 is a scalar, that's why the name is scalar multiplication. Is it clear? Okay. Next, matrix multiplication. So before the discussion of matrix multiplication, I would like to share a higher concept, namely inner product. Okay. First of all, inner product, I am giving you the definition first. Okay. Suppose I am considering a row matrix A1, B1 C1. Clearly this is a matrix and which is row matrix since only one row is there, and another column matrix A2 B2 C2. Here A2 B2 C2 are some numbers and A1 B1 C1 are number. So the first one is a row matrix, second one is a column matrix. Okay, so inner product of these two matrices will be, we will get back a scalar quantity. Okay, that is a matrix also of order 1 cross 1. So let it be. So the dot product of these two, that means the row and this column, will be the first element dot first element. That means we have to multiply this and this first with first, then we will get A1 A2. After that we have to use plus. We have to use plus. Next, second one is with second one. Then if we multiply these two, then B1 B2 plus the rest part C1 C2. So this is called inner product. So inner product we can apply with a row matrix and another one must be column matrix. Clear? As for example, suppose I am considering an example 2 3 5 dot 3 1 0. Then inner product of these two will be 2 into 3, that means 6, plus 3 into 1, that means 3, plus 5 into 0 means 0, equals to 6 plus 3 9. So inner product of this row matrix and this column matrix is 9. Clear? So we need this concept to multiply two matrices. Okay, so next I am going to discuss about matrix multiplication, which is the most important part for this chapter. Okay, more or less difficult. Okay, relatively tough it is. Relatively tough than addition and subtraction and scalar multiplication, which we have learned. Okay, so matrix multiplication you have to know. What is matrix multiplication? So let's go. Question arises that always is it possible to consider the inner product with a row matrix and a column matrix? Suppose I am considering a row matrix 2 3 5 and a column matrix 5 7, only this part. Now if we try to consider the inner product, then 2 multiplied with 5, very good, 10. 3 multiplied with 7, 21. So no element is there to multiply with 5. So inner product is not possible here. Okay, so when does inner product is possible? Inner product possible only when the number of entries in row matrix must be equal to number of entries in column matrix. See here, number of entries is 1 2 3, but here 1 2. We need here 3 elements. Clear? Next, matrix multiplication. So I will explain about matrix multiplication by considering an example. Okay, let A be a matrix and B is another matrix. Suppose this. Okay, then matrix multiplication of these two matrices A dot B denoted by this and defined by 2 5 3 1. Just I have written here the first matrix dot second matrix 5 2 1 3. Partly we will use the concept of inner product. Okay, so just try to remind, inner product was with a row matrix and another one should be a column matrix. So first if we consider the first row, this row, okay, then we need a column. So first we will use the first column, after that we will complete with second column also. Okay, so equals to by this row, if we consider the first column, then 2 into 5, 10 plus 3 into 1, that means 3. So this complete the inner product of this row and this column. After that, with this column. Okay, we consider this row and fix it and complete with each column. So first column done, now in second column. So if we consider the second column, then 2 into 2, 4 plus 3 into 3, 9. See, when we did with first column, we have written here. So when second column, then with in the place of second column. Okay, so with the first row, both of the column done. Next, consider the second row. Consider the second row and do the same. So with this row, first we have to do with the first column. So 5 into 5, 25 plus 1 into 1, 1. So this complete with first column. Now with second column, this row and this column. So 5 2s are 10 plus 3 1s are 3. Now simplify, then equals to 10 plus 3 equals to 13, 9 plus 4, 13, 26, 13. So this is the multiplication of A and B. Clear? Similarly, you can solve for BA. Okay, I am solving again BA. An unimportant message you will get from here. So if we try to solve BA, then B dot A equals to, we have to write first B. B means 5 2 1 3 dot A means 2 3 5 1. Okay, now multiply these two. Then first consider this row, first row and first column. Then 5 2s are 10 plus 5 2s are 10. Okay, so first row and first column done. Now first row with second column. Then 5 3s are 15 plus 2 1s are 2. So this complete with first row. Now consider second row. Then second row and this column. So 2 1s are 2 plus 15 and 3 1s are 3 with second column. 3 1s are 3 plus 3. After simplify, we will get 10 plus 10 20, 15 2 plus 17, 17 6. Now one important observation. See here, AB means 13 13 26 13 and BA means 20 17 17 6. Now question is, here AB and BA are equal? No. AB we get a result and BA is another result. So here the important is that AB not equals to BA. That means A dot B not equals to BA. So from this line we conclude that matrix multiplication is not commutative. Is it clear? This is a very important property for matrices, that matrix multiplication is not commutative. Okay, so this is the matrix multiplication, concept of matrix multiplication. Next, I told you in my beginning of this video that matrix addition, matrix subtraction, matrix multiplication, all these three operations possible, but with some restriction. And you got to know about the restriction for addition and subtraction. What is the restriction for addition and subtraction? For addition and subtraction, you need both of the matrices are of same order. Okay, but what is the restriction for matrix multiplication? Is the same restriction will be there, or more restriction we can change? See, matrix multiplication depends on row and with column. Okay, so if in any case number of element in row and number of element in column does not match, then we could not able to apply the concept of inner product, and that case matrix multiplication is not possible. Okay, I am considering an example. Suppose A is a matrix 2 3 1 5 and B is another matrix 2 3 5 1 7 2. Now try to simplify AB. Then A dot B equals to, you will face a problem, dot 2 3 5 1 7 2. So if you consider the first row of this matrix, then we have to do the inner product with first column. So now is it possible? 2 into 2 3 5, but no element is there, which you can multiply with 7. So inner product is not possible. Okay, so ultimately AB does not exist. AB not possible. It will be better, not possible. Okay, AB not possible. Now check BA possible or not. So to complete BA, you have to write B first. So B is 2 3 5 1 7 2. Dot A means 2 3 1 5. Now consider the first row and consider this column. Then inner product is possible. Why? 2 to the 4 and 3 1s are 3. So 4 plus 3 7. I am solving directly. Okay, and this row fixed. Now with second column with 3 to the 6 plus 3 5 are 15. 15 plus 6 21. Next, first row done. Next with second row. Do the same with second row. Then second row with first column. Then 5 to the 10 plus 1 11. See, I am considering second row, so I am generating here second row also. Now second row, second column. So 3 5 is 15 plus 5 20. Now this complete the second row. Now third row with first column. So 7 to the 14 plus 2. 14 plus 2 16. And 3 7 is 21 plus 10. That means 31. So this is BA. See, here AB not possible, but BA is possible. Okay. So which will you write here in case of matrix multiplication is not possible, or how to check that matrix multiplication is possible or not? Obviously process is there. See, the number of element along this, that means 1 2, this gives us the number of column. Okay, 1 2 means there are 2 column, and 1 2, if we count this number, then 1 2, this gives us number of row. So we can conclude from here that matrix multiplication is possible if number of column of first matrix, number of column of first matrix is equals to number of row in second matrix. Row of second matrix. This is the condition. Okay, so it is very tough to memorize it, that number of column. Actually, number of this element, so 1 2, this give us the number of column of first matrix, and if we count along this 1 2 3, then this gives us number of row of second matrix. So these two should be equal. Okay, so we can generate a formula from here. How? See, very important here. Just check that what was the order of this matrix. Order is row in number of row into number of column. So number of row is 1 2 3, and number of column 1 2. This is the order of first matrix, and order of second matrix is 2 cross 2. Okay, so this give us the number of column of first matrix, and these two gives us the number of row number of row of second matrix. Since first one is row, so if these two number equals, see, number of column of first matrix, that means this number, is equals to number of row of second matrix, that means this number. So these two numbers should be equal. Okay, so then matrix multiplication is possible. So we get a easy rule. We get an easy rule that if A is a matrix of order 5 cross 3 and B is a matrix of order 3, 4, then since these two number equal, so here A be possible, A dot be possible. And after multiplying the resulting matrix, resulting matrix means here B was this, A was this, but after multiplying we get this matrix. This is called resulting matrix. We can identify, or we get to know, okay, and we can say the order of the resulting matrix also. Order of resulting matrix will be the extremities. That means this to end. This to end means this end is 3 and this to end is 2. See, the order of this is 3 cross 2. Check it. Number of rows is 3 and number of columns is 2. So A be possible, and the order of AB, in this case order of AB will be 5 cross 4. Okay, these two extremities is 5 cross 4. Okay, so we can generate a rule from this concept. So I am writing in general that if A is a matrix and B is another matrix, if A is a matrix of order m cross n and this is the order of matrix m cross p, then since these two number equal, therefore A be possible. Because if C, we get the matrix C, then C will be of order m cross p. These two extremities, m cross p. A be possible, and the resulting matrix will be of order m cross p. Understood? So easily we can check that matrix multiplication is possible or not. Clear? Next some example. Just we will check that matrix multiplication possible or not. I am considering an example matrix A equals to 2, 3, 5, 1, 2, 4, 3, 1, 0. Okay. B is another matrix 1, 2, 5, 7, 3, 9. So now check whether AB and BA possible. So I am checking the first one, AB possible or not. So what is the order of A? Order of A is number of row is here 3 and number of column also 3. That means A is of order 3 cross 3. Okay, and B is of order number of row is 3 and column is 2. So since these two number equal, so matrix multiplication is possible. That means AB exists. Clear? Now for BA, if we check for BA, then we have to write BA first, after that A. So B is of order 3 cross 2 and A is of order 3 cross 3. Now check, these two numbers are not equal. These two are not equal, 2 and 3. So we can say that BA is not possible here. Understood? So this is the concept. So this almost the theory part of the chapter matrices. I will discuss more theory in my next video. So today's class is up to this. So take care.
Please subscribe my YouTube channel and press the bell icon so that you get the notification of all updates.